Hello everybody, my name is Devash Roy. I'm the Senior Network Trainer as well as Cisco Network Specialist at the Indian Cyber Security Solutions. And these are my contact information for LinkedIn and Twitter. Today I'm going to talk about QoS, Quality of Service. Now QoS is a method for congestion avoidance in case of router. We know that the serial interface of routers have a definite bandwidth and it has a capacity to handle a certain amount of traffic. And if too much traffic comes in the router interface, then it will cause congestion or traffic jam. If there is no congestion, no QoS policy should be implemented. But if there is congestion, yes, QoS is needed to avoid the congestion and to maintain the bandwidth of the router. Now the features of QoS. There are mainly 5 features or 5 points of QoS, that is classification, then marking, then queuing or scheduling, policing, and shaping. What is classification? Classification means we need to identify the incoming traffic. So we need to first identify what kind of traffic the router is going to receive. And mainly the traffic types in case of QoS are of 3 types, that is voice, video, and data. Voice means you can say any VoIP traffic or any voice related traffic, any audio clipping it may be. Video means any video data, any video stream, any live video stream, maybe YouTube live, Facebook live, all those things video stream can be there. And data means any normal data packet. So first we have to identify which type of data is coming to a router interface. Is it voice, is it video, or is it data? The second point, the second step is marking. Marking is actually assigning priority to the traffic. So we want to mark specific traffics and we want to assign priority because we cannot allow all the traffics to enter the router at the same time. So we have to assign priority to traffic. Now generally the voice traffic is assigned more priority than video or data because without voice it is not possible to communicate. Say for example, I am doing a Facebook live or YouTube live and nobody is able to hear my voice, but they can see me and they can also see my data, but it won't do. So voice is absolutely necessary for any communication. That is why voice traffic is given the most priority. Now there are 2 markings to assign the priority value to the data, voice, and video. That is DSCP, discretionary services code point, and COS, class of service markings are used. So these are different types of marking values that is used to mark traffic. Class of service is used to mark traffics in trunk links. In case of switch to switch trunk links or switch router trunk links in case of VLAN, we use class of service. And in other cases, in other normal traffic, we use DSCP marking. Then comes queuing. Queuing or scheduling means first we have to assign the priority to the traffic. Then the traffic has to be queued to the router. So there is a router scheduler, and in the scheduler the traffic should be queued. Means the traffic waits for its turn to enter the router interface. So we cannot allow all the traffic to enter the router at the same time, because if we do it, then there will be no point in assigning marking. We have to mark a certain traffic, we have to give priority to a certain traffic, and that traffic will be allowed first and then the other traffic. So it will be like a line by line process, a queuing process, a serial process. First the traffic which will get the highest priority will enter the router scheduler, and then the second one, and then the third one. So the traffic waits for its turn to enter the router interface. There are different types of queuing. WFQ, that is weighted fair queue, CBWFQ, class-based weighted fair queue, and LLQ, low latency queuing or low latency queue. So what are those things? So we'll understand now. See, say for example, this is my router and this is the scheduler. Here all the traffic is coming here, and here it is waiting for its turn. First is voice, second is say video, the second queue, and on third queue, that is data. So they are waiting to enter the router interface on the scheduler. Now if it's WFQ, weighted fair queue, then what happens? That randomly each traffic is assigned the priority, or you can say every traffic gets a fair amount of priority, almost equal amount of priority, voice, video, or data. So it means that nobody is getting any priority. So every traffic may enter the router interface, and again it may result in congestion. So that is WFQ, weighted fair queue. CBWFQ, class-based weighted fair queue, is we are then going for class, or we are then going for a specific type of traffic, not all traffic. Say for example, we say that yes, voice, video, and data all have same amount of priority, but we will assign a little bit of higher priority to voice. This voice traffic will be preferred. So this is CBWFQ, class-based weighted fair queue. We are assigning queuing, we are giving priority and queuing according to class or type. And LLQ means only one traffic will always get the highest priority. Say for example, I say the voice traffic will always get the highest priority. Say it will get the priority of say 70% priority, and video traffic will get 20% priority, and data traffic will get 10% priority. So that is low latency queuing, or LLQ, means you are assigning highest priority to a particular service always. It may be that it will result in congestion, but you will assign the highest priority to the voice traffic. Now this is not good, because the voice traffic will get almost the maximum priority, and so it will take the maximum amount of bandwidth. So there will be a little bandwidth left for video or data. So again, it will result, or it can result in congestion. So no method is totally ideal to avoid the congestion. The no scheduling process is totally ideal. And now this is policing. So now this policing and shaping, these are two methods to actually restrict the congestion or to avoid the congestion. I've already told you that congestion can never be totally avoided, but we can restrict it. Policing is a solution to the congestion router interface to avoid that congestion. It is a very restrictive policy. It restricts any traffic regardless of its priority. So for example, in the router interface, in the incoming interface, say voice, video, or data, any traffic comes, say it has a little bit of higher bandwidth. Say our router interface has a bandwidth of say 2 Mbps, and the traffic that is coming, it is 2.5 Mbps. So only 500 Mbps is more, 0.5 Mbps is more. But policing will not allow the traffic to enter the router interface, because it's a very restricted policy. If the bandwidth is a little bit more than the router serial interface, it will not allow the traffic to enter. This is the restrictive policy regardless of any priority, regardless of any traffic. It may be voice, it may be video or data, but it will restrict any traffic. And second is shaping. Shaping is also a policy to avoid the congestion, to restrict the traffic, but it is a bit lenient policy. It is less restrictive than policing. Means if it sees that any traffic is coming to its interface, to the router interface, and that traffic is having more bandwidth, then it will allow the traffic, but it will tell the traffic that you cannot enter the router interface at such a great bandwidth. You have to reduce the bandwidth. You have to say reduce the bandwidth to say 2.5 Mbps to 2.1 Mbps. Say for example, my router serial interface is having 2 Mbps bandwidth and the traffic is coming at a speed of 2.5 Mbps. But in case of shaping will ask the traffic to slow down the speed and then to enter. So it means one by one after one, packet 2, packet 3. This way the data will enter, not the entire data. So at a time, not the entire data will enter, but some pieces of data one by one serially will enter at a reduced bandwidth. So that is shaping. So that way shaping will allow the traffic to enter. Say for example, I need to provide voice traffic, but if the policing is there, policing will totally stop the voice traffic. So it is better to go for shaping. So these are the different policies to be implemented for router bandwidth control. If there is any congestion possibility, then this policing or shaping is implemented. So this is about the QS, quality of service in a nutshell. These are the main points of quality of service that I have shared with you today. I hope you have enjoyed it and I hope it was informative for you. So that's it for today. I'll come with some new topic some other day. Till then, it's goodbye.